Hi everyone, myself Dr. M. Lakshmi Prasad, working as an Associate Professor in the Department of Data Science in Institute of Aeronautical Engineering. So in this video, I'm going to discuss about conceptual data model. So what is conceptual data model? So how we're going to implement this model by getting the data from various sources that I'm going to discuss in this video. So by knowing this topic, the student can able to understand what is the basic concepts of conceptual data model. So once the data is given to get from the secondary, primary and administrative data sources. So that should be the course outcome of this topic. And in this video, I'm going to discuss about the basics of data models, and then uses of data model, and what are different types of data model, then what is the conceptual data model, how we're going to implement it, and what are the advantages and disadvantages of conceptual data model. So very first thing is that data modeling. So data modeling is nothing but the process of creating a data model for the data to be stored in the database, right? So the data modeling, nothing but it should be a process of creating the data model for the data to be stored in the database. So data model is the conceptual representation of data objects. Okay, so what is the data objects that are available that should be going to be represented through this data model, and then associations what are there in between the data, that is one to one, one to many, many to one, and many to many relationships. So that should be able to represent between the data objects and the rules here. And data modeling is going to help in the visual representation of the data, and then which can also enforces the business rules and regularity, compliances and government policies on the data itself. And these data models ensure the consistency in naming conventions and semantics, security, which while we are going to ensure the quality of the data here. Okay, the data modeling is nothing but the process of creating the data model for the data to be stored in the database, and the data model is the only way of conceptual representation of the data model by making use of relationships or associations in between the data objects and the rules. And this data modeling should also helps in the visual representation of the data as well, and then should also ensure the business rules and regularity, compliances and government policies on the data. And these data models can also ensure the consistency in the naming conventions, and then as well as the semantics and security while going to ensure the quality of the data. So the data model is going to be defined as the abstract model that organizes the data description and data semantics and the consistency constraints of the data. And this data model mainly emphasizes on what the data is going to be needed and how it is going to be organized instead of what operations have to be performed on the data. And this data model is like that an architect building plan which helps to build conceptual models and a set of relationship between the data items. There are two types of data modeling techniques that we can able to encounter. That one is entity relationship modeling and unified modeling. So these are the two types of data modeling techniques what we are having to present this data model. Okay, so the data model is going to be defined as the abstract data model, which is going to be organized this data, what a description, and then the data semantics and consistency of the constraints of the data. And this can also be emphasis on what the data is needed and then how it is going to be organized instead of what operations have to be performed on the data. And this data model is like architecture building plans which can also help this conceptual models and set up relationship between them. So totally we're having two modeling techniques. So first thing is entity relationship model that we already encountered in database management system and UML. So unified modeling language, this one you can able to obtain from the software engineering concepts. So the data model is the visual representation of core concepts. So what can able to define this, the data model is nothing but the graphical view of the core concepts that is important to the organization. So this data model can also be describe the business statements or the business problems also. So while when we're going to work with a business audience, there should the importance of data modeling is in occurs in communication only. Okay, then this data model create the ways to show the models to the business audience, and this normally this data model able to tell the story of the business how it looks like. Suppose if you look at this picture, they say the prospect or customer, what we are going to do is get the data from the customer, like his father, suppose, and then he's the client. What we're having, so these people are going to describe what the product is, and this the person salesperson which is going to sell this product and sells to that prospect also, and simultaneously this product is going to be trained by support representative how we're going to sell this product and all, how we're going to finally sell all the products in the best price in order to make the business success, right? So like this I can able to design the model how it I can able to represent, suppose if I want to selling a product, so for that how we're going to do that, how to know. So for that we have by using this data model only I can able to describe how this business is going to be run by means of communication only. And what are the uses of this data model? So the uses of this data model will be which can also ensure all the data objects that are required by the database are actually accurately represented or not. And under uses that the omission of data will lead to the creation of faulty reports, and then which can also produce incorrect results. So that should be eliminated by using this data model. And this data model can also helps in designing the database at the conceptual level as well as the physical level and then logical level of the data, right? So what are the uses of data model means that, so using this data model you can also ensures all the data objects what are required for the database and are accurately represented or not, you can able to properly guide it. And the omission of the data which may lead to the creation of faulty reports and then produce incorrect results is going to be omitted by make use of this data model. And this data model also helps in designing the database at different levels like conceptual level or physical level and logical level as well. And this data model should also helps in defining the relationship between the tables and primary and foreign keys and then store procedures as well. And it should also provide some clear picture of the base data and how it can be used by the database developers to the physical database. And it should also helpful to identify the missing and redundant data. So through the initial creation of the data model, that is labor and then time consuming, and then in the long run it makes your IT infrastructure upgradation and maintenance cheaper and faster, right? So this like this there are so many ways how the data model can helpful to the person to make this conceptual data modeling, right? So this data modeling helps able to define the relationship between the tables and primary keys and foreign keys and the stored procedures what are there in the database. And this data model can also be provide a clear picture of the base data how they are going to be used by the different database developers to create the physical database. And it also be helpful to identify the missing and redundant data. And through the initial creation of this data model, what will happen, so through this labor and then time consuming will be reduced, and in the long run it should be useful, and then your IT infrastructure should be upgraded, and the maintenance should also be cheaper and then faster as well. So like this we're having the different types of data model. In this one we're going to see different types of data model will be logical data modeling and physical data modeling, and we can able to do that creating and updating data as well. Okay, So in logical data modeling, so it should take the input of process models what we are having and the data requirements what are needed. So that should be injected to the logical data modeling, and this physical data modeling able to took this technical requirements and performance requirements. And so the creation or updating data should take the input from the business what is coming from various sources, right? Then once this input is done, then this logical data modeling is subject to the logical data model, and this one should be again sent to the physical data model. You should able to build this physical data model, and this physical model is going to be developed and required data is going to be produced here, right? So different types of data models will be logical modeling and then physical modeling, and then creating and updating the data is the main steps or various types of data model. So in logical modeling what we're going to do this is, so what type of process models we're having, so that should be going to be modeled into logical data, and this data requirements would also be converted to logical data. And what are the business technical requirements and performance requirements what are there, so that everything should be converted to physical data modeling. Okay, so once this data modeling is done, then we can able to construct this logical data model. Once this one should be sent as the input to the physical data model, and the physical data model should be constructed. Finally this one should be injected to for creating updating data, so that the actual data can able to get here. So there are different types of data models. So just now what I said. So there are mainly three different types of data models, like conceptual data models, logical data models, and then physical data models. For each and every model having some specific purpose. Okay, and these models are going to be used to represent the data mainly, and it is how it is going to be stored in the database to make the relationship between the data items. So that is the problem. So for that we're having this the data models of different types, and each one is having some specific purpose. So the very first one is the conceptual data model. So what is the conceptual data model? So this model able to define what the system contains. Okay, so that means how it is going to be, what kind of data are going to be modeled based on the system. That should be done through the conceptual data model, and this one should be created by the business stakeholders and data architects, and the purpose is to uh, uh, organize scope and define the business concepts and rules. Okay, so the conceptual model is going to define what the system contain, and this one should be created by two persons. So first one is that business stakeholders, and second one is data architects. And the main purpose of this conceptual data model is to organize and scope and define the business concepts and then rules. Next one is that logical data model. So this model defines how the system is to be implemented regardless of the data management system. And this model is typically created by the data architects and the business analysts as well. And the purpose is to develop a technical map of rules and data structures, right? So this logical model defines how the system is going to be implemented regarding by without considering the database management system, and this model is typically created by data architects and then business analysts, and the purpose is to develop the technical map of rules and then data structures. And the third one is that a physical data model. So physical data model describes how the system will be implemented using specific database management system. So that should be the physical data model. So this model able to describe how the system will be implemented using specific management system, and this one is going to be created by database administrator, that is DBA, and then developers, and the purpose implement is to implement the database system, right? So the previous one should be conceptual database. So this one able to define what the system contain, and this one should be created by business stakeholders and architects, and the purpose is to organizing scope and then defining the basic business concepts. And second one is that a logical data model, so it should able to define how the system is going to be implemented without considering DBMS. If we are going to consider DBMS, that should be the physical data model. Okay, but this logical data model is going to be created by data architects and business analysts, whereas this physical model is going to be created by database administrator and developers. And physical data model is going to be used to implement the database, whereas logical database, the purpose is to develop the technical map of rules and then data structures what we're going to be injected for creating this data model. And this see in detail about the conceptual data model. So the conceptual data model is nothing but an organization of database concepts and then relationships, and the main purpose is to establish the entities and then attributes and relationships. And in this data modeling level, there is hardly any detail available on the actual database structure is going to be identified, and business stakeholders and data architects typically is used to create the conceptual data model, right? So the conceptual data model is going to be organized in the view of database concepts and their relationship actually, and the main purpose is going to be establish what is the entity and what are the attributes what we are going to maintain and what kind of relationship between the data objects. That's and all we are going to see in detail through conceptual data model. And this modeling so should be a little bit hardly on the actual database what we are going to store the data. And business stakeholders and data architecture typically create the conceptual data model. So there are three elements of conceptual data model. So first one is that entity, what I said previously, and then attribute and relationship. So first one is that what is entity. So entity is nothing but a real world thing. Anything in the real world should be considered as an entity, and attribute is nothing but the characteristics of that thing or properties of an entity. And relationship, so relationship may be a dependency relationship, or it may be an association between the two entities. So the data model, is nothing but, suppose I'm going to consider one application like the customer and the product. So how we're going to represent this one through a conceptual data model. So the customer and product are the two entities I'm taking. So one is customer and there is product. So the customer number and name are the attributes of the customer entity. So customer name and customer number should be the entities of the attributes of customer entity. If I'm going to consider this product, so the name, product name and price will be the attributes of product, and the attributes of the customer will be customer name and customer number. And how can I able to represent the relationship between the two entities? So whether I can able to represent through association or I am able to represent the dependency, right? So this is the relationship what exists between customer and then product, right? So the basic terms of or tenets of this conceptual data model will be entity and then attribute and relationships. So entity means anything in the real world should be considered as an entity, and attribute is nothing but the properties or characteristics of the entity should be called as an attribute, and relationship should be it may be a dependency and association between the two entities. Okay, so the customer I am taking as one entity and product I am taking as another entity. So the customer name and then number should be considered as are the attributes of the customer, and then product name and product type should be considered as attributes of the product, and in between them I can able to establish the dependency relationship, or I can able to represent the entity association relationship. So this is the first one, the logical data model. So the logical data model is always used to define the structure of the data elements and to implement the relationship between them. and this data model adds further information to the conceptual data model elements. And the advantage of using this logical data model is to provide a foundation to form the base for the physical model as well. And however, the modeling structure remains generic here, right? So in logical data model, so this model is going to be especially modeled to define the structure of data elements what are maintaining and how are going to establish the relationship between them. And this logical data model further adds the information about the conceptual data model elements, and it should also provide some foundation for the physical data model also. That should become this advantage of the logical data model. And so similarly, how this conceptual data model, similarly the structure looks same, but the relationship is going to be different in logical data model. Suppose if I'm going to consider this customer entity, so previously I defined the attributes of this. So what type of attribute it is, whether it is a string or character, or it may be integer, float, what it is. So that thing I'm going to specify in logical data model. You see, conceptual data model, I'm not specifying these things here. So in detail information I'm going to specify. So that is the important thing of logical data model. Suppose if I'm consider the customer number, so integer I'm taking customer number. So what it is an integer, float, or character. That thing I have to represent here. So similarly product name, what it is a string or character or float or what it is. And then price, whether it is a float, integer, double, what it is. So detail information is going to be represented in a logical data model. Well, comes to the characteristics of logical data model, which can able to describe the data needs for a single project, but could integrate with the other logical data model based on the scope of the project. So the main characteristic logical data model is that, so the data and what is needed for implementing a single project should be integrated with other logical models. Okay, so based on the scope of the projects, and we should also be designed and developed independently from the DBMS, that is database management system. So the logical data model is to be designed and developed without considering this data management system, and the attributes what we are taking should have exactly specifies what type of data it is, and then what should be the exact precision and length also specified. So the normalization process what we are having DBMS is to be applied till 3NF in order to get the logical data model. Okay, so the logical data model able to describe the data for a single project that is integrated with other logical model based on the scope. We have to be identified or describe the data, and then the data is also be designed and developed without considering from DBMS, and then the attributes what we're having should able to specify exactly what type of data it is and what is the precision and the length of the data. So they normally the one normalization what is done that should be applied to this model until we are going to get the 3NF form. So here also the modeling structure remains generic, but at this data modeling there is no primary and secondary keys is to be defined, and then you can also need to verify and adjust the connector details between the relationship what exists between the two entities have to be identified. Right, so the modeling structure what should be having that should be remains generic. So at this data model we have to be identify that there is no primary and secondary keys is to be defined. At the same time, we have to be need to verify the what type of connector details we're providing between the two entities as a relationship. We have to be done very carefully. And next one is the physical data model. So this physical data model able to describes a physical database and then specific implementation of the data model, which should also offers database abstraction and helps to generate the schema. And so this is because of the richness of metadata that is going to be offered by the physical data model, and it also helps in visualizing the database structure by replicating the database column keys, constraints, indices, triggers, and other relational database features, right? So this physical model, once when it comes, so what will this model is able to do is it should be able to describe the detailed implementation, how the database is going to be implemented by considering the model, and it should also be offers the database abstraction and also helps for generating the schema. So because of this richness of metadata that is going to be offered by the physical data model, and it also helps in visualizing the database structure by replicating the database column keys what we're having, and then constraints, indices, triggers, and other relational database features. Right, so if you consider this physical data model, so previously what you have doing, so previously we are maintaining the customer name and what type of data it is up to here, we have seen, right? So once that one central physical model, so then you have to identify what type of primary key, and then what is the primary key, and then what is the secondary key, what is the unique key, then how to make the relationship between the one customer entity to another customer entity, and what kind of relationship in between them you have to establish. So whether it is one to one relationship, or one to many relationship, or many to many relationship, or many to one relationship, like this we're having relationship. So what type of relationship is to be established in between them, that one you have to be defined through the physical data model. So when it comes to the characteristics of this physical data model, so this physical data model able to describe the data that is needed for a single project or application. Through it may be integrated with the other physical data model based on the scope. Right. So the physical data model also be describes the data what is needed for a single project or entire whole application. Through it may be integrated with the other physical model based on the project scope. It also contains the relationship between the tables, which can that addresses the cardinality and the nullability of the relationship. Okay, so how many number of rows that is maintained in the table, that one have to be identified. So the cardinality, okay, and nullability, whether the table is maintaining any rows or not, what kind of relationship between the tables established. It also be contained in the physical data model, and it is also developed for specific version of the database management system, and then location and data storage or technology to be used in the product. Okay, so this physical model also be developed for what, not only for mm, uh, data storage purpose, but it also going to be used for what kind of specific version of database we are using, the location and the technology what are going to be used in the project will also be defined here. And the columns should have exact data types and length assigned and default values. So the primary and foreign keys and views, indices, access profiles, and authorization also be defined in physical data model. Okay, so the primary keys and secondary keys, views, indices, access profiles, and other authorizations also be defined in the physical data model. Finally comes to what are the advantages of this data model and disadvantages we'll see now. So when it comes to advantages of this data model, so the main goal of designing the data model is to make certain that the data objects offered by the functional team are represented accurately. So the main goal of this designing the data model is that to makes certain that the data objects what is offered by the functional team are to be represented accurately. This is one of the advantage. And the data models should be detailed enough to use for building the physical database. If I want to specify the physical database, then you have to make use of this data model only. That is another advantage. So the information in the data model can be used for defining the relationship between the tables, primary keys and foreign keys, and stored procedures, right? So the information what you're providing in data model should also be used for defining the relationship between the tables and primary keys, foreign keys, and the stored procedures. So this data model also helps business to communicate within and across the organization. So through this data model, so what will happen? The business people can able to communicate with each other, or they can able to communicate with other organization as well. And this data model helps to document the data mappings in ETL process. and it also helps to recognize the uh, uh, correct sources of the data to populate the model. So these are the various advantages of this data model. So the main goal of this design model is that to make certain that the objects are going to offer the functionality are properly represented, and it is also used for building the physical database, and this will also be used to make establish relationship between the tables and what kind of keys it is having, whether it may be primary or foreign key and store procedure. And the data model should also helps to business to communicate within and across the organizations, and it also helps to document the data mapping in ETL process, and also helps to recognize and correct the sources of data to populate the model. When it comes to disadvantages, the disadvantage is that in order to develop this data one model, so one should know what is the physical data uh, characteristics. So without knowing that, it is difficult to develop this data model. That should become one of the advantage. And another thing is that, so it is the navigational system uh, which can able to produces the complex application of development management. So that what will happen means it would require some knowledge of biological truth. So even a smaller change made in the structure requires a modification in the entire application at the other disadvantage. And there is no set of data manipulation languages in DBMS as well. So the disadvantages of this data model means, so first thing is that one should able to know the physical data characteristic. Without knowing that, the physical model should not be implemented, or what are the model should not be implemented properly. And suppose if the navigation system is able to produce some complex application development management, so at that time what will happen, it require some knowledge on the biological root, right? So that is the other disadvantage. And even a small change in the made in the structure, so it requires some modification. This is the other disadvantage. And there is no data manipulation language available in the database management system. So these are the disadvantages of the data model, right. So in this model I discussed what is the data modeling. uh, so what is data modeling? So data modeling is nothing but a process of creating the data model, and which can also be for the data going to be stored in the database. And this data model should be the conceptual representation of data objects, and also represent the relationship between the data objects and then rules. So the data model is going to be define the abstract model, what the data is going to be organized, and what kind of data description is there, data semantic and constraints of the data. So we are having two types of data modeling concepts. The first one is entity relationship model and UML model. So unified modeling language. So the data model is graphical view of the core concept that is important to the organization. And mainly this data model, if I want to represent through business means, then so based on the communication we can able to develop the data model. And the uses of data model will be ensures all the data objects that are required for the database are accurately represented or not, and omissions of the data like faulty reports and incorrect results. Producing incorrect results is going to be eliminated by making use of this model. And it should also be helps in the designing the database at the conceptual, physical and logical level, right? So this data model should also helps in defining the relation between the tables by making use of the primary keys, secondary keys and store procedure also. So it should also provide some clear picture of the data, and should also helpful in identifying the missing and redundant data. And types of the data model will be logical data modeling, physical data modeling and conceptual data modeling. Okay, so the conceptual modeling is going to be defines what the data system content should be this conceptual data model, and this should be supported or created by business stakeholders and data architects. And it should, the main purpose is that to organize, scope and define the business concepts and rules. And logical data model and physical data model describes how the system is implemented. Without considering DBMS should be logical model, with considering the DBMS should be physical model. Then conceptual data model is mainly used for organizing the views of the various database concepts and their relationships. So the main purpose is to establish entities, attributes, and relationships. And the main tenets of this conceptual data model is entity, attribute, and relationship. Anything in the real world should be considered as entity, and the characteristics or properties of an entity should be called as attribute, and the relationship between normally in between the two entities should be dependency and association relationship. So logical data model which can able to define the structure of data elements and the relationship between them, and logical data model able to add further information to the logical conceptual model. And advantage is that we can able to provide some foundation to the physical data model. And next thing is that physical data model which can able to describe the database implementation. So for that, what we have to do, it should also be helpful in generating the schema of the physical database model. And it also helps in visualizing the database structure by replicating database columns, keys, indexes, and then triggers and other database features. So advantages of the data model and disadvantages. So advantage is that to make the certain data objects are going to be offered by functionality want to be represented properly, and building the physical database, and then defining or establishing the relationship between primary, foreign keys, and store procedures, and establishing the communication within and across the organization, and documents mapping an ETL process, and recognizing the correct sources of the data. So these are all become the advantages of the data model. And disadvantages is that we have to be know the physical data characteristic for developing this data model, and we have to be know we should have some knowledge of biological truth, so that only you can able to implement this navigational system process. And even a small change in the structure itself requires a larger modification, and data manipulation language also needed. So these are the disadvantages of the data model.
Like, share and subscribe. Hit the bell icon for more updates.